All right, this is 5D notes. We're going to be factoring and solving polynomial equations today. All right, look at the following. You don't need to write it down on your notes, but look at the following. Here's a graph of a polynomial functions. Now recall that the real solutions to an equation is where it touches or crosses the x-axis. So here it appears that my solutions are x equals -1, x equals 2, and x is equal to 4. Okay, all right. So we're going to be looking at the following three methods today because we're factoring polynomials. So if there's two terms, we always look for a GCF, and it's going to be one of our special factoring, either dots, the difference of two squares, like a squared minus b squared, or sum set, the sum and difference of cubes. Three terms, that's our traditional factoring, a times c method. And then four terms, here again we always look for a GCF, but we're going to be factoring, seeing if we can factor by grouping. Now here's a reminder of the special, the patterns for sums and difference of cubes, and the difference of squares, which we call dots. The difference of two squares. That's where we're getting dots from. So it's all about recognizing these patterns at the time. Now you may need more paper than I provided for you, so maybe want to pause the video and get a couple sheets more paper to give yourself plenty of room to take these notes. All right, here's our first problem. We're going to factor completely and find the zero. So take a moment, write down that equation. All right, there's four terms here, so that means we're going to factor by grouping. So we're going to group the first two. Make sure that these are in standard form, and also make sure you factored out any GCF. So always look for a GCF first and factor that. Now since we're factoring, we're going to keep the GCF, but then we're going to go ahead and solve this too. All right, let's factor by grouping. So largest common factor would be 25p squared, which leaves me with p minus 1. Since my lead coefficient is negative, I need to pull out a -1, which leaves me with p minus 1. So we're going to end up with 25p squared minus 1, and then p minus 1 equal to 0. Now since we're asked to factor this completely, I've got to look, because in this third degree polynomial, I've got to look to see if I can factor again. Well, this is a linear term, so we can't factor that again. The power, the degree is 1. But look at the square term. This is the difference of two squares. This is dots. That means this factors to 5 minus p, 5 plus p, I'm sorry, 5p minus 1 times 5p plus 1 times p minus 1. So here this is factored completely. So some of your problems are going to ask you to factor, and then other problems are going to ask you to solve. So factor completely. Now let's solve. We're still going to use that zero product property, so we're going to set each factor equal to 0. And in this case, solve for p. So this is going to be 5p equals to 1. P is equal to 1/5. 5p is equal to -1. P is equal to -1/5, and then finally p is equal to 1. All right, so let's make a set of our answers here. We got -1/5, 1/5, and +1. All right, so four terms right now we're going to factor by grouping. So here again, make sure they're in standard form. Make sure there's no GCF. If there is, you need to factor that out. And then we're going to use the zero product property. All right, in class, I will be showing you a couple of different techniques to check your answers. All right, let's look at another example. All right, this has two terms. So factor completely and solve. So we got to see if this is going to be one of our methods. Dots, which is dealing with perfect squares. Well, 2 and 32 are not perfect squares. And x to the 4th is not a cube. Okay. So let's see what else we can do. 2 and 32. I notice I have a GCF. Now when I'm factoring, I got to keep that GCF. All right, now look at what we have left. All right, this is the difference of two squares because x to the 4th is a perfect square and 16 is a perfect square. And we have to have a minus. So now I can factor this into dots. So that's going to be x squared minus 4 x squared plus 4 equal to 0. Since this is a fourth degree equation, I know I'm going to have 4 solutions. Alright, we got to keep factoring. See if we can factor more, because factor completely. Look here. I have difference of squares again, so I can factor that x squared minus 4 into x plus 2, x minus 2, and then I have my x squared plus 4. Alright, now if I'm asked to factor, this is going to be my answer. Okay, I can't throw away that GCF of 2, because like I said, some of the problems are going to ask you to factor, and others you're going to have to solve. So you got to know when you can get rid of your GCF and when you can't. So since I ask you to factor completely, I need to keep that 2 for a moment. Alright, now let's solve. Let's set each 0 product property. Let's set each 0 or each factor equal to 0. Alright, so I'm going to get x is equal to negative 2, positive 2, x squared is equal to negative 4, square root both sides. I'm going to get plus or minus 2i. So this particular equation has 4 solutions, 2 real and 2 imaginary. So my set is negative 2i, positive 2i, negative 2, and 2. So the degree also tells you how many solutions you're going to have. Alright, so there's an example of dots. Difference of 2 squares. Alright. Alright, look at this one. So take a moment, write down that problem. Now this problem I can only factor it. I can't solve it because I have 2 variables, but I can factor it. Alright, it's 2 terms. It's going to be one of our special patterns. Well, I see to the 4th power, which is not a cube, and 81 is a perfect square, so this is going to be differences to 2 squares again. This is going to be dots again. So that's going to factor to c squared minus 9d squared. I'm taking the square root of both. And c squared plus 9d squared. Alright, look and see if we can factor anything else. Got to factor completely. Well, here again, difference of 2 squares. Always look at the ones with a minus to see if you can factor again. The plus one's not going to, because that's to be a difference. Alright, so this is going to factor, so it'll be dots again. So c minus 3d, c plus 3d, and then c squared plus 9d squared. So now it's factored completely. And like I said, I can't solve it because I've got 2 variables. Alright, let's look at using 3 terms, our A times C method. Alright, so take a moment, write this down, factor and solve for all reals. So let's write down the following question. 4x to the 4th minus 9x squared plus 2 equal to 0. Alright, so here again, it's in standard form. I don't have a GCF. So now let's look to, we're going to go A times C. So it multiplies to give you 8, but adds to give you negative 9. So negative 8 and negative 1. Alright, now notice this time, we're used to dealing with x squared and then x in the middle, but I'm going to treat this the exact same way, just my variable, my middle term is going to have an x squared in it. You're going to see it works out the same way. So 4x to the 4th, going to rewrite that middle term as negative 8x squared, because that's an x squared, plus negative 1x squared plus 2. We're going to group the first 2, group the second 2. I'm just doing my A times C method. Alright, greatest common factor is 4x squared, leaving me with x squared minus 2. Here, I need to pull out a negative 1, leaving me with x squared minus 2. Alright, let's put it back together. So my factors are 4x minus 1 and x squared minus 2 equal to 0. Alright, we're asked to factor. So let's see if we can factor anything else. Alright, look at the first one. It's a minus. 4 and 1 are both perfect squares, so that I can use dots to factor that first polynomial. So we got 2x minus 1, 2x plus 1. Alright, this is a minus, but 2 is not a perfect square, so I can't do anything to that. Alright, let's use our 0 product property. Set each factor equal to 0. And think back again, how many answers should we have? The fourth degree, so I should have 4 answers. So we're going to have 2x equals 1, x equals 1/2, 2x equals -1, x is equal to -1/2, and then x squared equals 2, so x is equal to plus or minus the square root of 2. Alright, so those are all my answers. So I got negative square root of 2, -1/2, 1/2, and positive square root of 2. So 4 solutions is a fourth degree equation. Fourth degree equations are called quartics. Okay? A cubic is a third degree equation, and a quadratic is a second degree equation. Alright. Alright, write down the following question. X to the fourth plus 2x squared y squared minus 15y to the fourth. Here again, something like this, I can only factor it. I can't solve it because we have 2 variables. Alright, what method? There's 3 terms, so I'm going to try A times C method. Alright, let's see that. Let's see. So my lead coefficient is 1, so I'm going to get negative 15. Multiplies to give me negative 15, but has a difference of positive 2. So 5 and negative 3. Alright, we're going to rewrite that middle term as plus 5x squared y squared, because that's what my middle term is, plus negative 3x squared y squared minus 15y to the fourth. I'm still doing the same technique. Doesn't matter what my variable is, I just treat my variables the same way. Whatever my middle term is, that's how I'm going to rewrite it. Alright, let's group the first 2 and group the second 2. Alright, GCF, what do I got? An x squared. So I'm left with x squared plus 5y squared. Alright, here I'm going to pull out what? A negative 3y squared. So that leaves me with an x squared plus 5y squared. Alright, remember these have to be the same in order to be correct. Alright, so my first factor is x squared minus 3y squared, and then x squared plus 5y squared. Alright, look to see if we can factor again. Or a minus 1 might factor, but 3 is not a perfect square, so that's the best I can do. But look always at the minus 1 and make sure that you can factor again. Also here again, make sure you're looking for GCFs at the very beginning. Or when you get to the end, look to make sure these have nothing in common. Otherwise you didn't pull out a GCF and it's not factored completely. Alright, a couple more. Alright, write down the following. Factor completely and find the solutions. We have x to the third plus 2x squared minus 15x equals 0. Alright, so make a note here. When solving, never divide by a variable. This thing should have 3 solutions because this is degree. Even though there's a common factor of x here, I have to keep that x. I can't divide by a variable. If I do that, that gets rid of one of my solutions. That's one of my factors. You can divide by a constant in an equation, constant GCF, but you can never divide by a variable GCF because we're not allowed to divide by 0. And a solution to our equation may be 0. You don't know what your variable is. That's why you can't divide by the variable. Alright, let's factor. This is 3 terms, so we're going to factor A times C method. So what multiplies to give us negative 15, but has a difference of 2. Well, this is familiar. We just did this. 5 and negative 3. Alright, I've got my x. You can't throw that away. Alright, keep that to factor completely. No matter whenever you're factoring, you got to keep your GCF. Alright, so here what am I get? Lead coefficient is 1, so I can go directly to my factors of x plus 5, x minus 3 equals to 0. Alright, so there's it factored completely. Now to find the zeros, we're going to set each x equal to 0. 0 product property. So x equals 0 is a solution, x equals negative 5, and x equals positive 3. So my 3 answers are negative 5, 0, and 3. Alright, here again, never divide by a variable. Always wrong math. It's going to be you're throwing away your solution. Alright, write down this problem. Factor and find the real zeros. So you've got 2x to the 5th minus 18x to the 3rd equals 0. Alright, look at this. It's two terms, but I don't have any perfect squares and I don't have any cubes. But I do see that I have a common factor. I have 2x to the third. So that's going to leave me x squared minus 9 equals 0. Alright, look at this. Can we factor this again? Hopefully, so that's dots. So we can factor it to x minus 3, x plus 3 equal to 0. Alright, now set each factor equal to 0. So we have 2x to the third equals 0. So x to the third is equal to 0. The cube root of 0 is just 0. This counts 3 times because that degree, this is called like a triple root. And when we start graphing these things, I'll show you what it's going to do to our graph. Alright, here we get x minus 3 equal to 0, x plus 3 equal to 0. So x is equal to 3 and x is equal to negative 3. So we're getting our 5 because, like I said, this is a triple root. So 1, 2, 3, 4, 5. So negative 3, 0, and 3. Alright, that's your notes. If you have any questions, please write them down so you remember to ask them in class.